particle is moving in a circular orbit of radius 10 meters. At one instant, the speed of the particle is 10 meters per second and is increasing the rate of 10 meters per second, square second. The angle between the velocity vector and the resultant acceleration vector of the particle at that instant. I will consider if the path is like this. Acceleration, tangential acceleration is 10 meters per square second. They have given tangential velocity is increasing at the rate 10 meters per square second. And there is a centripetal acceleration for any circular motion. This centripetal acceleration is changing with time because of velocity is changing. Magnitude of velocity is changing. We can get centripetal acceleration for this situation. Omega v squared over r. We can use v omega, omega squared over omega squared r or v squared over r. Now they have given velocity, therefore we have to use v squared over r. V squared is 10 into 10 divided by radius 10. Now tangential acceleration also 10 meters per square second. Therefore, resultant acceleration should be in this direction. This angle is 45. There is the same magnitude, therefore resultant should be midway. Then we have to find the angle between velocity vector and resultant acceleration vector. Velocity vector is in this direction. Resultant acceleration is this direction. We have to get this angle, it also 45 degrees. Then answer should be 3. Figure shows a space colony of radius 10 to the power 3 meters rotating about its axis. At what angular speed omega must the space colony be rotated so that astronauts standing in the flow of the colony experience a push on his feet that equals weight of the Earth. It means the acceleration towards the center should be equal to gravitational acceleration on Earth's surface. We can get acceleration towards the center is, we can use these three relationships, but we have to find the angular velocity. Therefore, we can use omega squared r. Then omega squared r should be gravitational acceleration, it is 10. We have to find omega. Radius is 10 to the power 3. Then we can get omega value 10 to the power minus 2 square root 0.1 radians per second. Answer is 1. A small object of mass m is suspended by a string of length L and is allowed to move in horizontal circular path about its vertical axis passing through O as shown in the figure. If the air resistance is negligible, velocity of the particle. We can get tension is in this direction. They have given this angle is theta. Therefore, this angle also theta, alternate. Then we can use vertical equilibrium. Upward force E cos theta should be equal to downward force weight of this particle. It is first equation. Then we can use S equals ma towards the center. Force is E sin theta. M into, we can substitute acceleration by using these three relationships. But we have to find the velocity, therefore I will substitute v squared over r. It is the second equation. Then we can divide second equation by first one. E is cancelling. Sin theta divided by cos theta tan theta. M is cancelling. V squared divided by Rg. Now we know that radius is, this length is given as L, radius should be L sin theta. Then we can substitute r value as L sin theta. Tan theta equals to v squared divided by L sin theta g. Then we can bring this term to this side. Lg tan theta sin theta square root is equal to the velocity. Lg sin theta tan theta root. Then answer is 1. The car of mass M monotile, a circular bend of radius of curvature r in horizontal that road with a speed u. If the car skids, then mu is the coefficient of friction between road and the tire. We can get that for the circular motion, the friction on car towards the center is the centripetal force. Then we can use F equals ma towards the center. Force is frictional force, we can write it mu r equals ma. When considering vertical equilibrium, r is equal and opposite to mg. Therefore, we can substitute r value as mg. We can substitute a value. A is centripetal acceleration. There are three relationships, v omega, omega squared r, and v squared over r. We have to get the relationships with velocity. Then I will substitute v squared over r. Then v value is mu gr root. This one is the maximum velocity for the car to avoid skidding. But if the v is greater than this value, mu gr root, car will skid. Then we can obtain first one is the correct answer. The athlete run a 10 km race with a constant speed v1 and v2 in a circular track of 50 meters. It has been observed that athletes with v1 speed complete 10 rounds when other athletes complete 9 rounds. The ratio v1 over v2 is. We can get time taken to complete 10 rounds by first athlete. T means period. It means time taken to complete a full revolution. T1 times 10 is time taken to get complete 10 circular paths. It should be equal to T2 times 9. T2 is the period for second athlete. We know that period is 2 pi r over v. Then we can substitute T1 2 pi r over v1 into 10. T2 is 2 pi r, same radius, same path, but velocity is a different value v2. We can cancel out 2 pi r. Then we can subject v1 over v2 ratio. It is 10 over 9. Then answer is 1. One end of two identical stretched springs are fixed to the two ends of closed tube band. The other end of a spring are attached to a mass M as shown in the figure. Which of the following motion of the system results in the displacement of mass M towards P from the center of the tube? Statement A. Uniform acceleration of tube in the direction PQ, keeping the tube horizontal. Yes, we know that when tube is accelerating in this direction, this mass will move towards P. Statement A is correct. We have to remember that for object, if the density of object is greater than outer medium, it will move against the acceleration. If the density of object is less than outer medium, it will move towards the acceleration. Then part B, rotation of tube around vertical axis pass through Q, keeping the tube horizontal. There is a rotation around this end. It means there is an acceleration in same direction towards Q. Therefore, this one will move towards P. B also correct. C, vertical motion of tube under gravity keeping Q below P. Q below P, it means this side. There is an acceleration under the gravity. Therefore, object will move towards P. C also correct. All A, B, C correct. Then answer is 5. There is an error in statement C. We can consider forces when it is moving vertically downward direction. Under the gravity, it will maintain weightlessness. It means when moving under the gravity, this object will not move in upward direction. C is incorrect. Then answer is 2. I will explain it. We can consider this object. Weight is in downward direction. Then we can use X equals ma towards the acceleration. There is only one force, it is mg, should be equals to acceleration mg, acceleration g. This one is the relationship. Therefore, there is no an extra force. It means there is no a force due to this spring or this one on this object. Therefore, both these strings are not changing its length. It means this object will not move upward or downward relative to the spring. Then C is incorrect. A light spiral spring has an unstretched length L and a spring constant K. A small object of mass M is attached to one end of the spring and the system is rotated about a vertical axis that passes through a small light ring attached to the other end of the spring as shown in the figure. If the object travels along circular path of radius r with constant angular speed omega, keeping the spring constant, keeping the spring on the horizontal plane, then we have to get the omega value. Initial length is L. When rotating, its radius capital R. Therefore, increasement of length is R minus L. We can use F equals ma towards the center. Force is K times extension. Now we can substitute the extension is R minus L. M into, we can substitute A, omega squared R. Omega squared R. Then we can find omega value. K divided by M, R minus L divided by R, foot. Answer is 1. An object is moving in a circular path at a constant speed v as shown in the figure. The change in velocity of object when moving from A to B. A to B means this position to this position. Change of velocity. Magnitude is same. It is not changing. There is only a direction change. we can get change of velocity v in this direction, final velocity, minus v in this direction, initial velocity. Final velocity minus initial velocity is the change of velocity. Then we can get minus v means plus v in opposite direction. Now v in this direction and v in this direction, we have to add vectors. Then resultant is this one. And we know that it is, we can use Pythagoras theorem, v squared plus v squared, 2v squared root 2v. And this angle is 45 degrees. Root 2v with 45 degrees. Then answer is 4. The small object is placed inside the right circular cone with axis vertical and vertex down as shown in the figure. The coefficient of static friction between the inner surface of the cone and object is mu. What is the maximum angular velocity of rotation of the cone and the object of the cone about its axis for the object to be on the inner surface of cone without slipping at a distance d away from the axis. I will mark forces. This one is the object. There is a reaction in this side perpendicular to surface. Weight is downward and there is a friction in along the surface. This object is trying to move in this direction. Therefore, friction should be in this direction. We can write it as mu r. Friction is mu r. This angle is theta. Then we can get this angle also theta. Again this one theta. It means this angle also theta. Now I will write the equation for acceleration towards the center. We can use Sp equals ma. Force towards the center, we have to get this component of this r force. This one is 90 minus theta. Now this one is theta. I will draw a large diagram. It will be useful to understand angles. mg r mu r. This angle is theta. Then we can draw a right angle triangle like this. We can obtain this one is 90. This angle is 90 minus theta. It means this angle is theta. And this angle also theta. Then we can use F equals ma towards the center. There is a force component of r cos theta. And there is a force component of mu r sin theta towards the center. It should be equal to ma. We can substitute it as the omega squared r. R means d. Now I will get r as a common factor. Cos theta plus mu sin theta equals m omega squared d. It is the first equation. Then we can get the vertical equilibrium. Upward force on the object r sin theta should be equal to downward forces mg plus mu r cos theta. Again I will get r term to the left hand side. R sin theta minus mu r cos theta equals mg. Then I will get r as a common factor. Sin theta minus mu cos theta equals mg. It is the second equation. Now we can divide first equation and second one. R is cancelling. Cos theta plus mu sin theta divided by sin theta minus mu cos theta. M is cancelling. Omega square d divided by g. Then we can subject omega. Omega equals g over d cos theta plus mu sin theta divided by sin theta minus mu cos theta square root. G divided by d cos theta minus mu sin plus mu sin theta divided by sin theta minus mu cos theta. Then we can obtain third one is the correct answer. A ball released at point A travels from the frictionless track as shown in the figure. Then the ball just touches the point B on the inner surface of the circular part of the track of radius r. What is the velocity of ball at B? We have given that just touches. It means you can get forces on the ball at point B, weight and r. When it just touches, r should be 0. Then we can get F equals ma towards the center. Force is mg. M v squared over r. We can cancel out m and m. R is given as, radius is given as capital R. Then root gr is v. Then answer is 2.